Hi, my name is Alberto Whitlatch, and today we're going to be talking about synthetic division. The goals for today's lesson are for you to be able to accurately use synthetic division to find the quotient of two polynomials. And I also want you to be able to accurately use synthetic division in the remainder theorem to find f of k for some function f of x, specifically a polynomial function. So let's start off by talking about the division algorithm. The division algorithm, what it basically says is that if you have some function f of x and a function g of x which has a lesser degree than f of x, is that you can divide them. Okay, so you can divide f of x by g of x, and there will exist a unique q of x known as the quotient, such that g of x times q of x plus r of x, which is your remainder, would equal to f of x. This is what it basically is saying to you here with the division algorithm. One thing that we do need to specify is that g of x does have to be of degree 1 or more. Now r of x will always be equal to 0, or the degree of r of x is going to be less than the degree of g of x. Now let's talk about how we could divide polynomials. What we've already learned is how to divide polynomials using a standard division algorithm. So that's where we would set it up with the polynomial that we're trying to divide in here, and what we're dividing by over here, in this case our binomial. And the way I'd start this off is by saying 3x cubed. If I divide 3x cubed by x, that's going to give me 3x squared. Now I'm going to multiply my binomial by 3x squared, and it gets me this. The next step would be to subtract from the above polynomial. And now I'm going to bring down, so after I subtract, I get 10x squared, and I will bring down my next term. One important thing to notice here, the 0x, you don't see it written up here, but there is no x term up in this polynomial. So we need to make sure that we have a placeholder here for 0x. Now I'm going to repeat the process, same way. So 10x squared divided by x is 10x. Multiply, subtract, bring down the next term, and repeat the process one more time. And this gives me that my quotient is 3x squared plus 10x plus 40, and my remainder is 10. Okay, so now let's talk about how we could use that same problem, so using synthetic division. First of all, let's talk about synthetic division. Synthetic division only works if I'm dividing a polynomial by a binomial in the form of x minus k. So that means it has to be of degree 1 for a synthetic division to work. It has to be a linear term. Okay, so let's go ahead and see how we would set this up for synthetic division. First thing that we'd want to do is write up our terms here. But before that, let's talk about where did I get this 4 from. The 4 comes from it's the additive inverse for my linear term here, my binomial that I'm dividing by. Now the 3 comes from, is the coefficient there, and this is my coefficient for my square product. Then I have the 0, and then I have my coefficient for my constant term. First thing I'm going to do is I'm going to just bring down the 3. Now I'm going to multiply 4 by 3 to get 12. Add them up and you get 10. Now you're going to multiply 40, add them up, you get 40, multiply them, 160. And you get that your remainder is 10. So right here, you can see that it's going to give us the same thing as we had before. Awesome. So let's go through one more example here of using synthetic division. So first thing, I have my additive inverse, and I have my coefficients listed there. I bring down my first term, I multiply, and I get negative 10. Then I would have negative 2 times 16 is 32. Add them up, 4. And following that same process, just by adding up each time, I end up with my remainder being negative 10. So this one, I could just write up this way, with my quotient being written in blue, and my remainder is negative 10. Now let's talk real quick about the remainder theorem. What the remainder theorem is saying is that if I have a polynomial, f of x, and it's divided by x minus k, then the remainder is equal to f of k. This can be very useful for us. Let's look at an example here. So let's have f of x be equal to this here, and I want to use the remainder theorem to find what f of negative 3 is. So I can use synthetic division in order to find this. So set it up here. I put negative 3 in here, and I'm going to write up all my coefficients. Now remember, if I am missing one of my terms here, make sure you have the 0 in there. Bring down the first one, multiply, add, multiply, add, multiply, add, multiply, add. And the last term is what would be our remainder. So then, according to the remainder theorem, that means that f of negative 3 is equal to negative 47. Now, let's take a look at this. Up to now, all our examples and everything have been only involving integers. And we want to make sure that I show you an example of something that would involve a complex number. So now I'm going to use the remainder theorem to find f of 2 plus I, okay, for when f of x is x squared minus 5x plus 1. So same thing, I'm going to set up, put my 2 plus I here, bring down my first term. Now I'm going to multiply 2 plus I times 1, 2 plus I. Add them up. I'd have negative 3 plus I. Now I multiply 2 plus I times negative 3 times I. And you'd get negative 7 minus I. And the last step is to add them up. So that means that our remainder would be negative 6 minus I. So by the remainder theorem, the solution, or f of 2 plus I, is equal to negative 6 minus I. So again, I wanted to remind you, this is a short lesson. The goals for this lesson are to be able to accurately use synthetic division to find the quotient of two polynomials, and to be able to accurately use synthetic division and the remainder theorem to find f of k for some polynomial f of x. Thanks again for listening and watching this video, and I look forward to making